All right. So in this video today, I want to do a homework help question on section 7.3. And I have chosen question 13 from the homework to look at. And you should be seeing my number 13. Now, obviously, your questions may change, right? Or not the question, but the numbers may change a little bit on your own end, but it's going to be the same general process. And you can probably see I've already answered the question because I did want to run through it one time before I started the recording and make sure I had my notes ready. But I'm going to run through this question with you guys today. There's two reasons why I wanted to go through this example. One is this is a p-value style question, and it uses the t-distribution. And I know in the lecture notes, we only did one example. So I want to do another one here so you have one more to watch. And the second reason is because this is the part of chapter 7 that is most relevant for the second project. So in the second project, you are not going to know the population standard deviation. So you're going to have to use t-distributions there throughout the project instead of the normal or z distribution. And again, you're asked to use p-values on the hypothesis testing part. So I thought it'd be good to run through it one more time so you can see the flow of the process there. So let's read through this question together. And I do have my camera, so I'll write down some key information and I'll show you and go through the steps. So it says, you receive a brochure from a large university. The brochure indicates that the mean class size for full-time faculty is fewer than 32 students. And you want to test this claim. So what we're being told here basically is the claim is based on what the brochure is advertising. So our claim, and again, I'm just going to write these keynotes down, is that the mean class size for full-time faculty is fewer than 32 students. Okay. I also see that we're going to randomly select 18 classes by full-time faculty and determine the class size of each. So if we're selecting 18 classes, our sample size is 18. And that is your n. So n represents sample size when we're going through formulas and things like that. So that will be our n value. We do have the data shown, so I'm not going to copy all the data points down right this moment, but we'll come back to the data in a second. And I do know that my alpha is 0.10 here. Okay, and we're going to go through, we're going to answer some questions. I am assuming that the population is normally distributed, so I do see that as well. So the population is normal. All right, and now we're going to go through and it's going to ask us a few questions on hypothesis testing, but we're going to go through all parts because you actually really need to do all the parts to actually answer just the 4 questions that are here. So I'm going to start sharing my other screen with you guys. All right, I guess I have to. Camera. So I'm just going to make this a little bit bigger on my end anyway. Okay. So you should see the basic information now. And I just, again, wrote down the key points here. And I want to run through the process of hypothesis testing with you. So you do have this in your notes. My numbers may not line up exactly, but they should be pretty consistent. So the first thing you want to do when you're hypothesis testing is you do need to do what I like to call the requirement check or your background check. Now for means, you're going to have the same requirement check, whether you're using the Z or the T distribution, it doesn't matter. So you need to make sure that either n is greater than or equal to 30 or your population is normally distributed. Okay. Here, my sample size is only 18, so it's definitely not over 30, but my population is normally distributed. We're told that as part of the problem. So we can go ahead and just check that off. you're going to notice that when you do the project that your sample size is going to be 40. So you're going to end up satisfying this other piece. So you'll be able to proceed and actually go ahead and do those confidence intervals and all that hypothesis testing. But you are required to do that background check before you start. The other thing we're going to notice here is that the sigma, which is the population standard deviation, is unknown. So when it's unknown, you are using these t distribution instead. Okay, so again, as a side note, if sigma is known, then you're using the normal or the z distribution. And that's also true for confidence intervals in chapter 6, as it is for hypothesis testing in chapter 7. So you have the same distinctions there. All right, once you've done that, you're going to go ahead and set up your claim and your two hypotheses. So you have your null hypothesis and you have your alternative hypothesis. And if I go up to the top, I did write down that we were trying to test if the mean class size was fewer than 32 students. So fewer is another way to say less than. So we're looking at this symbol here. And the symbol for the mean is that Greek letter M, that mu. So our claim is that the mean is less than 32. All right. Now, the claim is going to be either the null hypothesis or the alternative. It's got to go in one of the spots. So you can tell the difference based on the sign. So your null hypothesis always has some sort of equality. So your symbol is this, this, or this. Whereas your alternative hypothesis has to be either less than, greater than, or not equal to. So you're going to take your claim first, see what kind of symbol it has, and then decide where it would fit. Because we're doing strict less than, it has to be the alternative hypothesis here. And then whichever one you don't fill in, it's going to be the opposite. So the opposite of less than is greater than. But you do need equality for the null. So it's going to be greater than or equal to. So the null piece will always have an equal piece to it somewhere, whereas the alternative will always be strict less than, greater than, or not equal to. All right, after you've done that, the third thing you do is, in this part you don't have to actually do anything, is you're just going to make sure you know what your alpha is, because that's going to be your significance level. And it's going to help you when it comes time to actually test that p-value. So again, you don't have to do any work here. It's just good to note it. So if you look at the steps in your text, that's like the third thing, is to just identify your alpha. All right. Now, for steps 4 here, or, you know, kind of 4, 5, 6, I kind of tend to put them mostly together. But at this point, we're sort of looking at finding that test statistic. We can draw our picture, figure out what kind of test we're looking at here. So one thing I am going to note is, because my alternative hypothesis has a less than symbol, then I do have a left-tailed test. So your alternative hypothesis is the one that determines what kind of test you have here. So just as a side note, if it's a less than symbol, you always have a left-tailed test. If it's a greater than symbol, you have a right-tailed test. And if it's a not equal to symbol, you have a two-tailed test. So I'm just going to draw a quick picture here. I do know everything is normal, so I'm going to have a bell curve. I'm using the t-distribution, which is also a bell curve, so the pictures look very similar, whether you're doing z's or t's. It's, again, almost the same. And I'm using a left-tailed test here. So basically what I need to find here is I need to find my test statistic. And that's going to be this t-value that I'm looking for. And it's a left-tailed test, so I'm looking at this area on the left. And this area here will equal my p-value. Sorry, my There we go. I said it froze a little bit. There we go. Now, when you're doing p-values, it's best to do it with technology. So I'm going to show you a couple ways that you can do it with technology, depending on if you're using the calculator or if you're not using the calculator. But before we get there, I am going to find my test statistic. So your formula here for the test statistic is T equals the sample mean minus the population mean over the standard deviation over the square root of n. Now, this mu here is from your null hypothesis. So whatever number you have in the null hypothesis, so here it's 32, that's going to be what the mu is. Our n in this case, we already know is 18, that's our sample size, but I do need the sample mean and the sample standard deviation. Now, on a regular homework question, these are normally given to you. I chose one where they're not given to you because that's what's going to happen on the project. You're going to have to actually find it yourself. So to go ahead and find that, you can do it a few different ways. You can either use Excel if you want. So you can choose what works for you. You can use Excel or you can use your calculator. And when we use our calculator, we're going to enter our data in L1. And then we're going to go ahead, let me grab my calculator. And click stat, calc, and then one var stats. Way back from what we did at the beginning of the semester in chapter 2. So we can find our sample mean, our standard deviation that way. You can also do it by hand, but the standard deviation is very difficult because you have to make that big long chart and subtract and square everything. So I highly recommend you do what's easiest for you. Either you're going to use Excel or you can go ahead and use your calculator to find the sample mean and the variance. So I use my calculator. I'll show you what that looks like. So for 1 second here, I'm going to go back to my question. So what I'm doing is I'm taking this data right here. Okay, so you have that little double box there. So if you want to use Excel, you just click that double box and it will copy that table into an Excel file typically for you. So you can do that if you prefer Excel. I'm going to use the calculator. So I'm just going to take this data set here and enter it into my calculator, which I already did. So let me show you what that looks like. Zoom out a little bit. All right, so here's my calculator. And to enter your data, you're going to press the stat button first. And then if you hit edit, you'll be able to enter your data set in L1. And I already did that. So stat and edit. So I did that before we started. So I had it all ready to go. So I entered my data set. And once your data set is in there, then you're going to press that stat button again. Go over to calc up top. Hit the one var stats key. And then you can enter L1 here. So my L1 is right down here. So I do second one, and then I hit enter. And I'll be able to get those key values. So on your calculator, your sample mean is given with the X bar. So I'm just going to round that to 2 decimal places here. And then your sample standard deviation is given with the SX. I don't know why there we go. It's a little off, SX. So 4.22. So now that I have those values, I can go ahead and plug them into my formula. So I'm going to have 30.06 minus the mean value here was 32. My standard deviation is 4.22, and then I'm dividing that by the square root of 18. And when you divide this all on your calculator, you should get about negative 1.95. Okay, so give that a try at home. If you're not getting the right answer, then just take your time, simplify the numerator, simplify the denominator, use all the decimals, and divide it out again. So you should have about negative 1.95. So this value here is negative 1.95. I'm going to call this steps like 4 through 6 if you're kind of following along in the text. All right, so the next thing we do, the final calculation piece, is we are going to find our p-value. And I'm going to do this with technology. And there's a couple different ways you can do it with technology. I'm just going to show you one. But the p-value is this area right here. That's what we're looking for. So one way we can do it with technology, if you're using the calculator, is you're going to press that stat button again. And this time you're going to go over to test. And you want to choose a t-test. Okay, so we're going to take our calculator out here. I'm going to press that stat button again. I'm going to go over to test this time. And just be careful, because we're using a t distribution, we're going to choose t-test. If you were using a z, you would choose the z one. So you just want to be careful. We're using t's here. So I'm going to choose t-test. You want to make sure the stats button here is selected typically so that you can enter your values. So your mu sub 0 is your hypothesis. So our hypothesis was 32. So you enter 32. Your x bar is your sample mean. So I'm just going to round that and do 30.06. Your SX is your standard deviation. And your N is your 18. So we tell our calculator those main values. And what it's going to spit out on the right is actually both your test statistic, which we just did by hand, kind of. So you can see over here, we just got that value, that negative 1.95 is also right there. But under it, that P is your p-value. So our p-value here is about 0.0339. Now, on the project as well, if you're using your calculator, then you don't have to do this by hand. You're more than welcome to just use the t-test for both the test statistic and the p-value. That's totally fine with me. So you would just, for your work, you would explain the process on the calculator, and that's okay too. I wanted to do this by hand as well because some students may not be using the same calculator, so I can show you how to do it otherwise. But if you have the calculator, it's pretty nice because you can get both of these values at once. One other thing I have to point out here, and I forgot to mention, is you do need to make sure that you select which kind of test you have. So I had already selected it, but remember that our alternative hypothesis said less than. So you're going to make sure you select the one that says less than. And you can see that the picture matches our picture here. If I select not equal to, you can see it now becomes a two-tailed test. If I select the greater than sign, it becomes a right-tailed test. So that's also really important. In our case, we're looking at a left-tailed test. It's less than. So I do need to make sure I select the correct type of test on my calculator, or else my p-value and my will be totally wrong. Okay. So double check that your picture is matching what you're seeing if you're using the calculator app. Now, if you don't have the calculator app at home, that's okay. I did find a free online calculator for the p-value for t-tests. There is a table in the back of the book, but it only gives you an approximate p-value. It can't give you the exact value there. So I found, again, like I said, a online calculator that you can use instead. So let me show you that. All right, I have so many things open. Where is it? All right, hang on one second, guys. There it is, okay. All right, now I found it. All right, so this is what it looks like. It is linked. So, I mean, you do have the link up top here, but it is linked in an announcement that I sent at the start of the week, I believe. So if you look at our Blackboard course, a couple announcements ago, I did put a link in there that has the link to here. So you can see it up top in the video, obviously, and just copy that down. But if you go to our Blackboard course, you'll see it in the announcements too. So you can see it's already on the T distribution here. It actually has other distributions too. So if you're not using the calculator, you could use it for the normal distribution as well. We're not covering the chi-squared or the F distribution, so don't worry about those two. So I'm going to select t-distribution. Now, your degrees of freedom is always one less than your sample size. So our sample size is 18, so my degrees of freedom will be 17. Okay, so it's always one smaller than your sample size. You do have to enter what the t-value was, so you would have to calculate that by hand like we did. So it was negative 1.95. You don't have to worry about the p-value because we're going to find that, but you do have to decide what kind of test it is. It is a left-tailed test. So once you do that, it will probably get filled in, but if you're not sure, just hit compute p-value. And again, it got filled in automatically, but it'll be right there. So all we're entering is our degrees of freedom, the t-value we calculated using that formula where we subtracted with the mean and divided. And then you do have to select which type of test it is, and it will give you your p-value that way. So this online calculator is going to be really helpful for you if you're not using the calculator. So you're going to want to use this for the homework questions, and you're going to want to use this for the project so that you have an accurate answer, not just a rounded answer from the table. All right, so all the work stuff is done. So the final two steps are the interpretation. So we have our p-value, we have all of our calculations, and step 7 is deciding if we're going to actually reject the null hypothesis or accept it. And to find this out, you're going to compare your p-value and your alpha. So if your p-value is less than or equal to alpha, you are going to reject the null hypothesis. And if your p-value is greater than alpha, then you will fail to reject the null hypothesis. So what I usually like to do here is I will just kind of set it up and write p-value, I'll write alpha, and I'll fill in my answers. So our p-value was 0.0339, and our alpha we said was 0.10. So if I compare these together, if you're not sure how to compare them, line them up decimal-wise. Okay, and then go column by column. So these are both the same, but on the next column, I see the 1 is bigger than 0, so this is the bigger one. So 0.03 is smaller than 0.10. So if we are smaller than 0.10, well, if our p-value is smaller, we're going to go ahead and reject the null hypothesis. So for this particular problem, we're going to reject the null hypothesis. And our final part here, which sometimes is the hardest part, is to interpret the result. So once you have, are you rejecting or not rejecting the null, you have to decide on, can you support the claim or can you not support the claim? Okay, so for part 8 is basically, do you support claim or not support the claim? And that's going to be based on part 7. So notice here that we chose to reject the null hypothesis. So I want to go back to my hypothesis statements. And I'm going to reject the null hypothesis. So basically I'm saying, hey, if I'm rejecting this, this is bad, right? I'm throwing that out, I'm rejecting it. So if I'm rejecting the null hypothesis, then it must mean that the other one is good, right? It's kind of like a black or white thing here where it's one's bad and one's good sort of idea. So if the null hypothesis is bad and being rejected, it must mean that the other part was correct or was good. In this particular case, our alternative hypothesis happened to be our claim. So we're basically saying in this example that, well, this is bad, this is good, so our claim looks pretty good. So we do have enough evidence. So yes, we have enough evidence to support the claim that that mean is less than 32 students. And again, this is going to depend on what happens for 7 and then also where your claim is, right? So if our claim was the null here, then we would have had the opposite result, right? We would have crossed out the claim and said, no, there was no evidence. So it depends on where your claim is. And then also for part 7, what's being crossed out, kind of what is we're saying is not the correct answer. So here we do have evidence to support the claim that the mean size is truly less than 32 students based on our sample. All right, so that's the process. Again, my numbering may be a little bit off from the text here, but you kind of have hopefully the right idea. So your first 3 steps are sort of your background. So getting set up, getting organized, stating that null, alternative, and claim. Your next 3 steps, sort of like 4 through 6, are really drawing your picture, what kind of test do you have, doing your test statistic, doing your p-values. So it's all the calculation work. And then your last couple steps are the interpretation. So are you rejecting the null? Are you not rejecting the null? And then what does that mean for your claim? So either you're going to support the claim or you are not going to support the claim. It's going to be one or the other. We never prove anything, so that's why we use the wording of support the claim or fail to support the claim or don't support the claim. So I'm not proving the claim, but at this point our evidence supports it.